All right, we're going live. This is our first live stream on YouTube. Pretty exciting. Just saves me about 10 minutes at the end of the class. I don't have to move my video over from Zoom. All right, so let me share my screen here. Yeah, me too. No, with Zoom, I can like turn it off. I can adjust stuff here. I don't know what I'm doing. Okay, so here's our folder. Do you all have access to this? To this folder? Okay, let me share. Okay, so there's at least you have access. You can download it if you want to download stuff. So I added a new folder called analysis. Today we'll upload a few data tables into analysis after we create them. So, but let me go over in admin. I just created this lesson plans. This will be like cover what we're doing today in week 3 and then week 4 and 5. So today in week 3, we finished a few things in script 2 that we started last week. So last week we created the covariate term start year from term start date to term start year. Today we're going to take birth date and we're going to create birth year, which is the same idea. And then we're going to create another covariate called TermStartAge. So I'll show you how to reorder columns inside of a data frame and how to export your data table as an Excel file. So that will finish script 2. And then in script 3, we'll start doing we'll cover queries, grouping, and merging. So the queries are actually a pretty basic function. Searching for rows by some criteria, searching by columns, searching by rows and columns. That's a pretty basic criteria or function. I should have probably covered that last week before we jumped into creating covariates, but we'll cover that today. Then we'll actually use the query to create a new covariate. And this is really, I think these two are one of the kind of highlights of today. How to create a covariate, how to create a new variable using a query on other values in your table. And then we'll do the group by and aggregation functions. This is the other kind of main theme for today. And I'll also cover pivot and melt, how to pivot your table. And then next week, there are a couple of things. Week 4 was going to be, is mostly visualization. So we'll definitely cover bar graphs and line graphs. But next week, we'll also cover kind of how to create time series data. This is a little bit complicated. Using the group by function, sometimes the merge function. But anyways, we'll create time series data, and we'll also merge. I'll show you how to use the merge function where you're merging two tables together. And week 5 is the statistical tests and models. So we'll do t-tests, and we may do regression and pick up any other kind of final topics. So firstly, let's go to the data. You'll see here a new file called KZ Ministries. I'm going to delete that for now. So these KZ ministries are the unzipped version of this file, and I didn't change anything in this data. So I'm going to leave that as is. And then if you go to the scripts, I've created so 1 and 2 here are the original scripts from weeks 1 and 2. And then this is the extra code that I put into week 2 and the extra, and my week 3 script. I'm actually going to do these from scratch today, but I'll leave these up here for right now in case you want to refer to them because they have everything. By the end of today, I'll have new script 2 and script 3, and then I'll delete those. But these are just kind of, you can refer to these. This is just my prep files. So I'm gonna go into my week 2 script here. So this is where we left off last week. We mounted the drive. We have our data path here. We concatenated all of these ministry files into a single data set, and we started recoding variables. We recoded the ministry variable using a dictionary. That's one way to recode qualitative variables, categorical variables. We also used a function to recode variables, to parse years, and then we also just use a straight up kind of equal, setting a column equal to a value. So these are 3 different ways that you can recode variables. So that's what we did last time. There are a few changes I want to make to this file. First of all, in path data, I'm going to rename this ministries, path data ministries, because the path to the data itself, right? There's this ministries folder, but the data folder itself doesn't. Today we want to put a data file in the data folder. So that's different than inside of this KZ ministries folder. So here I have data KZ ministries. So I'm just going to call that path data ministries. And then I'm going to copy this and just create path data and delete ministries here. So now I've got 2 paths, right? One to the data folder and then one to the KZ ministries folder inside of the data folder, right? So now I've got two different path variables. So if I run path data, let's see here. So we should probably start from the beginning. And if we want to mount, it's going to prompt us to connect to Google Drive. So again, like everything that I'm doing right here is already in you can follow along in the scripts in this week 3 prep script. It has everything that I've done already today, but I'm just doing it fresh here in this here. So, okay, so path data. Now, if you run here, there's nothing. That's just the folders, right? So I need to replace. Right now, I'm doing. Right now, I'm working in 2 pandas. Everything I'm doing right now, I already did. I've already done it all in this week 3 prep file. But I'm just kind of doing it again from scratch here. So you can follow along in here, right? But here I'm doing it kind of in real time. Yep. I call this recoding with dictionary and apply. Yeah. Okay. Oops. Recoding with dictionary and apply. Yeah, okay, so first I'm just adding this new path, but then I have to update that to path ministries. That's going to give me the ministries. Okay, and then here in the data, I have to update its data path ministries. Okay, and then here's the file list of the ministries that we made last week. And now in here, when I'm going to loop through those file names, I have to, when I'm opening up the new file, I have to change this path, right? From path data to path ministries. So I'm just trying to be precise with the paths because later I'm going to need a path to the data folder, not, inside the KZ ministries. So I'm reading all these in and concatenating them. Okay, now I have my data file with 207 rows. So this is where we were last week. And info. So you can see all of these variables or all of these data types. And I mentioned last week the kind of equivalence from Python to Pandas data types. Like in Python, an int, if you have an int in Python, in Pandas, there's an int 64. Right? If you have float in Python, in Pandas has float 64. Boolean is Boolean. And then all of these objects like a string or a list or a dictionary in Python, in Pandas, those will all be coded as a object data type, right? So right now, these are all objects, and most of them are strings. One of the differences we talked about last week is int64 can handle missing values, can handle NA values, whereas a Python int, if your column in the data frame is coded as int, and then you have a missing value, it's gonna, and you try to run any function on it, it's gonna throw errors because it doesn't, when it finds an NA value, it says, oh, that's not an int, I can't do that. But if you change them to int64, Pandas knows how to handle NA values and just kind of skips over it, right? So there's a real advantage when you're coding data types in Pandas to use the Pandas data types, not the Python data types, because it just handles missing values much better. Okay, so we were recoding variables last week. So we recoded the ministry using this dictionary. I'm just going to zip through the code. There's one other thing I wanted to change here. I want to change term start date. I'm not going to actually change I want to create a new variable called term start year. So this is a little bit different from last week. Instead of saving the new value on top of the old one, I just want to create a new variable. So you'll see here, I'm still going to run this code, recast it as a string. Here are the unique values. Here's the function that we created to parse the year. We'll still run that. Right. The difference is right here. When I'm going to run the function, and before I was going to write it on top of the original variable. Today I don't want to do that. I want to just create a new variable called term start year. And also, one thing I should say, I didn't mention this last week. It was my mistake. If you use the dot, it's not going to create a new variable. Right? So to create a new variable, this term start year, you need to use the brackets and the name of the variable like this. So I'm running the parse year function on term start date, and then I'm gonna create save that as a new variable called term start year, right? And then I can use the dot form, the dot to get the variable, right? Just to see what it is. Okay, so there, term start year is, and it's saved as an object, right? And then here I just want to recast it as, again, not TermStartDate, but I want to recast TermStartYear as type int64. Right? So TermStartYear equals TermStartYear as type int64. And there are some missing values in there. It doesn't matter, right? With int64, it can handle that. So I do that. Okay. So now you can see I've got integers here. They're saved as the data type is int64, right? So, okay. So I'm going to do this with position. I had some, these are all ministries, but they're all ministers, but whoever, like my assistant who inputted the code, sometimes they call them Minister of Science or Minister of Education or just minister. I'm just going to write over all of those minister, right? So, okay, and now you can see they're all minister. Okay, so that's where we were last week. Today, I want to create one more. So what are we doing? We're creating one more covariate birth year. And then, so for birth year, actually, I'm not going to, because birth year is really similar to this term start date, right? I'm going to just copy this block, copy, and go down here and just paste. And now you can see I have this block of code and this block of code. And I'm just going to adapt the second block of code from birth. Let's see. So if you look at dat columns, we've got, okay, so there's a birth term start year, right? That's the new variable that we created. And here I've got birth date. And I'm going to redo this code here. So for birth date. And I'm going to create a new variable called birth year. Okay, so here I'm just going to adapt all of this code. So it was term start date. So this is birth date. Okay, so now remember we wrote that function parse year to parse the year out of term start date, but the structure of these dates are slightly different. So you'll notice that all of these dates are, day, month, year. Notice that there's an ND here, right? So anything that's like a n.d, we're going to code that as a missing value. Notice there's one other problematic one in here, this one with this space. That's a problem because in our last function, we split on spaces, right? And in this case, I don't want to split on spaces. So what I'm talking about is right here, this value, right? So now we could go into the data and just like manually adjust it, but I don't think we really need to do that here. We just need to change our function a little bit. So again, I'm changing all of this from birth date. I'm going to cast it as a string, and then look at the unique values. So we've got the NDs, and we have this one with a space in there, but that's about it. So this is a little bit easier to parse than last time. We don't have the extra like date stamp or whatever. So here with define parse year, I'm going to change this. I'm just going to change the function name to parse birth year, right? From parse year, let me close it. So I'm going to adapt this function just a little bit. First of all, I don't need to split on the white space. So I'm just going to comment that out. Right? The way I comment is you push control and then the // and that will comment. Okay, then the first thing I want to do is convert these NDs to, well, notice that this ND has a space afterwards. So if I say, is this value n.d, and it will say, no, that's not n.d, that's n.d space, right? So, and I might have other spaces elsewhere. So if the first thing I'm going to do is strip any white space, right? So here S is like the text value that I'm entering. So first, or the string. So first I'm going to set string as, I'm just going to strip white space. And then the second thing I'm going to do is if S is n.d, I'm going to define new year. New year is the value that I'm going to return. I'm going to define new year as npnan, which is a null value, right? So if the string is n.d, then I'm going to define new year as a null value, as an na. Else, then I can handle it however. Else, everything else has a dot, right? So here I don't need an if statement. I'm just going to move straight into my else statement. So basically, if it's n.d, then it's a missing value. Else, I'm going to define new year as s.split. I'm going to split on the period, right? Now, what is this going to give me? Let's say I put this value in. If I split that on a period, what's that going to return? What data type is it going to return? If you take a string and you split on a delimiter, right, like a period, what's that split function going to return? Nope, it's going to return a list. It's going to return a list with strings, right? So this, if you split this on a period, it's going to return a list with 3 values. Right? It's going to return a list with 15, a list 02, and this year, right? So here, so last time we split, and then we took the value that had 4, right? That was 4, length 4. But the issue is here, this has a white space, right? So if you split on the period, this is going to return white space plus 4 values, right? So the length of that string is not going to be 4, it's going to be 5. Yeah, so how can we make that 4? So I can do a little bit more processing. So here I'm going to split, and that's going to return the list with the 3 values, right? I'm going to use this same list constructor here. Okay, Y for Y in new year. So what new year is now a list with these 3 values, right? Now for each value in new year, I'm going to strip white space. Okay. Yep. So inside of this list, now for new year is a list with 3 things. For each of those things in the list, strip any white space, right? So let me just let's say we can just apply this to let's just try it outside. Let's say S. Let's say this is S. Okay. So let's say we have this, and then we're going to split, and then we'll return. Well, hold on. We'll do these like step by step. Okay, so if I run that, right, it's a list with 3 values. Let's say I have a white space in there. Now that white space is included in that string, right, along with 1957. So if I ran this, give me New Year where the length is 4, it's going to return an empty value because none of them have length 4, right? It's either length 2 or length 5, right? So if we add this extra one here, right, that strip, it's going to strip each one at a time, right? So for each of the, now New Year's this list, for each item in that list, strip the white space from that value, right? So that's going to, this is kind of how you pre-process items in a list. You just use this constructor, and then whatever you want to do to pre-process, you do it on that, right? And now if we take 4, right? Now we take the one that's 4, and there's 1957. Right? So that's what's going on here. All of this other stuff I can delete. Delete that. Yeah, this is from last. So because last time I also had numbers, just like years by themselves, and here like everything has everything is going to be converted to a list. So, okay. So then if the length of New Year is greater than 0, then take the first value. Otherwise, I don't need this because if it's not that, it's already null. Okay, and then I'll return New Year, and let's just print out New Year. Oops. Okay, so now we can run this. Oh, but we don't want to run parse. We want to run this new function, parse BirthYear. Okay. So you can see here when it printed out the values. Sometimes it printed out an empty value. Maybe I'll put that in there. It'll print because, but it should just. Oh yeah, maybe it's not printing. Yeah, it'll just up. Oh, I haven't run it yet. Yeah. Now it'll print out as a NaN. Okay, so that's fine, but it's still an object. Okay, so whatever that thing is, now I want to serve it. I want to save it as birth year, right? And this was birth date, and this is the birth year function. Float. Where are we? I'm not happy if it's. I think these should be inside here. Sorry. Because it's either NPN and this is, these are inside of the else. So let's try this. Hopefully. Okay, yeah, so it ran that. And now it's still object type, but we want to change this to birth year to int64. And now it's in 64. Okay, so if I run dat info, now term start year and birth year are both in 64s, right? Okay, so we've created birth year, and now we want to create term start age. So let's step back a second and look at the data real fast. Okay, so we've got the ministry, we've got the term start date. We now have this term start year. We took the birth date, and now we have the birth year. You can see that we just grabbed the year out of there. How do we calculate the age of the minister at the time that they were appointed a minister? Term start. Yeah. So we're only going to deal with the years now, right? So now the date strings are, we're just going to leave those alone, right? Because those are strings and they're annoying and they're like, so now we can, yeah, so we can take term start year minus birth year, and that will give us, let's call that term start age. So that's the age when they became a minister. So I'm going to create a new term start age. Okay, this is super easy to, this is another way to create a new covariate, right? We're going to create term start age. So we define that column by placing the name of the column in the square brackets, right? And here we don't need an apply function. We don't need a dictionary. We can just take the column names. We can just subtract the columns directly. And this notation, you know, although it's technically a column minus a column, when you write it like this for simple operations like minus or plus or something or divide, Pandas knows what you mean. What you really mean is row by row, take the term start year in that row and subtract the birth year in that row, and it knows how to do that. So let's do that. Okay. So now we have term start age, 55, 57, right? And notice the data type is in 64 because term start year and birth year were also in 64, right? So now if we look at that info, we've got 3 in 64s here, right? Okay, so we've got term start age. Great. This is one of the main variables that we wanted to analyze. Okay, so we've got the covariates, and now let's export the file. And before we do that, I just want to show you how we can reorder columns too, just in case you want to do that. So let's look at, I'm going to create a new export KZ Ministries. So first thing, so here under, you know, as I'm preparing to export, I'm going to reformat the column order just a little bit. So again, if you look at how might we want to reorder the columns? I mean, it's not important, like it's not, you know, critical. But let's say we wanted to kind of organize the columns a little bit to make it cleaner. Yeah. Okay. Yeah, and in fact, maybe we can just drop the date, right? We can drop term and date. We can drop birth date, and maybe we can just drop those. And then, so let's kind of. So what I do to do this is you just look at print out the columns here and just grab that list. And then let's reorder columns equals that list. Okay. Now all you have to do is write the column names in the order that you want, right? So let's do ministry, and then I'm just going to delete term start date because I'm not going to use that in my analysis, right? I'm not going to use term end date right now. Let's keep position, name, birth date. I'm not going to use that either. I'm not going to use URL or notes either. So I've got. So yeah, so my raw data, I'm not going to write this. I'm not going to write this new data over the top of the old one, right? Because remember, the old data is that like each ministry has its own file, right? Now I have a one data set with all the ministry data, and I'm just kind of cleaning up that data set before I export it as an Excel file. And then in the future, now this is script number 2, right? So in the future, starting with script number 3, 4, 5, I don't have to reconcatenate all the data. I'm just going to open up the new one clean data set that I created, right? So this is why I number my scripts 1, 2, 3, because some of the earlier scripts are going to create a nicer, cleaner data set that the later scripts are going to open up, right? So okay, so position, name, term start year, term birth date, term start age, and if we want, like, let's move name to the end, like we could do that if we want, whatever. So okay, so I'm just creating a list. Okay, now the next thing here, this is the key. So dat equals, well, okay, so I can just put in the column here, dat reorder columns, right? So if you do dat with the square bracket, and then you put this list in here, right? This is the same as if I wrote this, right? I mean, it's essentially, it's the same thing. Inside of the square brackets for the data frame, you're putting a list with the columns, and then that will show you the columns that you selected. So, but because this can be messy, I just create a list as a and then put that list in there, and then, okay. So I still have 207 rows, birth year, term start age, name, much cleaner, right? Okay, this is the data that I want to export now as my new data set. So, but if I look at, be careful, because if I look at dat, I didn't change dat. That's still the old thing. Save this. Okay, now dat is that clean data. Okay, now I want to export that. So to export, you're going to need a file name. So we'll call this file out name equals, I'm going to call this KZ Ministries, and you need to put in the data type, or sorry, the file suffix, right? So XLSX, I'm just creating a string, a file name, and then dat. Here you take the data frame, and then you use the function to Excel. So this is it's a pandas function on a data frame, right? So you take the data frame dat, use the to Excel function, and now we can put in the path. So which path do we want? Let's go back up here and look at the paths. This is why I created these paths earlier. So I've got path data, and I've got path data KZ Ministries. Yeah. So the second one, this ministries, this was the folder, where I could go in and grab the raw data from the ministry folder. But I don't want to, that's not where I want to save the new data. I want to save it just in the data folder, right? So I'm going to take path data plus my new file name, which is this file out name. Okay. And I'm just going to run that. Okay, so if we go to scripts now, let's go to the data folder and refresh this. Okay, right, and there it is, ministries.xlsx. And if you open that up, this will be our clean data. Now, notice that there's this kind of annoying index. Remember, data frames have these index in front, right? Like, here's this index here. So it exports that index unless you tell it not to. So I almost never, I don't need the index because Excel has its own index, right? Like you've got the rows are already indexed here. So if you want to get rid of this, you just, inside the 2XL formula, you just add a parameter index equals false. And just run that. And now notice like my Excel spreadsheet is still open, but that's fine, right? I mean, because this is Google Docs, it's going to update automatically, right? And now we've gotten rid of that index. All right, so here's our data. Now you don't have to export your data at the end of every script, right? Sometimes when you're doing analysis, you're not changing the data file. You're just looking at different views. You're looking at different, queries, and the data is like staying the same. But in the beginning, like in the first few files, if you're formatting, if you're merging, if you're like creating a new file, then oftentimes at the very end of the script, you're going to take whatever data frame you've created and you're going to export it as a new data file. And even with the data, if I plan to do more formatting on this, I would also number these, like 1 KZ Ministries, 2 whatever, so that in the future I would know these data sets are kind of created in sequence. But for our purposes, this is it, right? I'm not going to create any other version of this. Okay, so I'm going to close this. Okay, so we've created these covariates. We reordered columns. We exported Excel. So now let's get into script 3, where we're actually going to do some queries and start grouping and aggregating and really wrangling the data. Okay, so this file is done, script 2. I'm going to close that. And I'm going to take that file, copy it, and make script 3. All right, so this is going to be script 3, pandas, query, group by merge. Now a full version of this script is already here, right? But I'm just going to with you here. So if we go into script 3, now most of this I'm going to delete, right? Because this is stuff that I did in script 2 that I don't really need. I'm going to keep the mounting the drive. I'm going to keep these paths. I don't need to play with the ministry directories anymore because I already concatenated that data into the new data set, right? So I'm going to delete that. Okay, I don't need to concatenate. I don't need to recode here. I don't need to export the file. So these I'm going to control select. Right, and then I'm just going to delete them. So all I've done is copy the header, right, the libraries and IO, because this stuff will be useful. Also, I'm going to add one more path. I'm going to add a path to analysis, right? And this is, if we go back out to the folders here, we've got data, scripts, analysis. I'm going to create, I've already created these here, but I'm going to create a path to analysis. So this is where I'll output analysis. And I may not use these data paths to ministries or data anymore, but I don't need to delete them. I just kind of like leave them. And so sometimes when my by the time I'm in like script 7 or 8 or 9, like my list of paths may just be like super long, right? But I just leave them there just in case if I ever need them, I can go back and get them again. Okay, so let's run the front end, and I'm gonna have to mount the drive again. Okay, were you guys able to create the birth year and the term start year? Were you able to create that in your own code?
Not making it in the same place.
Okay, is it the function was causing you some trouble, or what's the?
Because of the past, we downloaded the drive from you. So we needed the solution type to set it up.
Okay.
So
okay.
We have to work it out with code.
Okay. Okay. So if you so next week I mean, now that you have access to this tutorial, you can just download everything, in advance, and then the scripts. I'll have the prep scripts up here that you can follow as you go along, or you can create the new script and make it with me. Okay, so here's the libraries, and then what are we going to do? So first, we'll import first we have to import the data, right? So if you look at, so we're going to import the data that we just saved, right, in this new file. So we're going to import this clean data. So that's going to be pd.readExcel. We're going to grab that from this path data, and I guess I should create a new file in name is kzministries.xlsx, right? So this is the file that we want to read in. That's the name of the file. So if we put, So for the path, it's just data science tutorial /analysis. Right now, we're not using that because we're just grabbing the data in the data folder, which is here. So here's the file name, and then I'm going to read in that. Okay, so there's the data. There's our clean data, which we created. But look at this. If I do dat info, notice anything unexpected? Yeah, we went from int to float, right? Now this is because when you export from Python Pandas into Excel or into Google Sheet, right, in the Google Doc, it's Excel kind of takes that data and it does whatever it wants with it, right? So Excel took those integers and Excel kind of converted them to floats, right? So now when you come back into when Pandas kind of takes that Excel file and opens it again, right? Like your new script doesn't know that in your last script those were ints, right? And so it now it's treating them like floats, right? So I mean it's fine, like the numbers are the same, but now they're integers instead of they're decimals instead of integers, right? So if you want a little bit of control over that, so this is where this is why we want to just control the data type. So you could cast these one at a time, right? So you could take like you could take BirthYear as type int 64, and then you do, right? Like you could cast them one at a time if you want, but that's really annoying, right? Especially if you have a lot of variables. So when you use this read Excel function to read in a data set from an Excel file, there's also there's a parameter in the read Excel function here, pandas.readExcel. It's called data type, dtype. So normally dtype is none, and the script just kind of figures it out, right? But if you go down to dtype here, you can either type in a name, you can say like everything's an object or everything's an int, right? Or you can use a dictionary from the column name to the type, right? So this is actually quite useful if you're especially if you're using the same data again and again and again. Then every time that you open up that data, why not tell Pandas exactly what data type you want it to interpret it as, right? So I'm gonna show you how to do that. You're gonna make a dictionary, and then save that for this is a data type parameter, which is in the read Excel function. So okay, so we're gonna go here. We're gonna create a data type dictionary. We're going to use dat columns to start, right? So these are the columns that we want to cast, whose types we want to cast. So we've got ministry, we've got position, we've got term start year, we've got birth date, we've got term start age, and we've got name, right? Now, but this has to be a dictionary, not a list, right? So first thing you have to do, change these to the curly brackets, right? Okay, so now it's a dictionary, but a dictionary has to be key, colon, value, comma, right? So the key is the column name. The value is the data type. So what data type is ministry going to be? It's going to be an object, yeah. Anything else is going to be, what else is going to be an object? Position, yeah, so position and name, right. Okay. Now term start year, birth year, and term start age, what are these going to be? In 64s, right. So we want these to be the in 64. So we type in 64. It's a little bit annoying to format, but again, once you've got this dictionary, right? So you'll just put this at the top of every file as a parameter. And now when you do the read in, when you read Excel, let's, so first let me run this. And then we're gonna run this again. But here we're gonna add the data type. Remember, so this data type parameter, we're gonna set it equal to this dictionary. And then we'll read it in and check out the info. And now you can see the term start year, birth year, and term start age are in 64s, right? So if you're just cleaning data and you're wrangling data and you're messing around with it and like you're going to change it and you're only going to do one script or something, you don't need to do this, right? But if you have like a standardized data set that you're using every single time and the data types are like fixed, then this is setting up this data type dictionary and then using that to cast your data types as you read them in from Excel. Like it saves you a lot of time. So, and it's just it's just cleaner. Okay, so that's read data type. So now this is one thing querying rows and columns. This is like a really simple, one of the most important things about data frames. Like that we didn't cover last week that I should have. So I'm going to cover that now. So we're going to query rows and columns. So query, let's see, this would be rows, columns, and then rows and columns together. And then after that, we're going to do, create a covariate. So let me just set that up here. Okay, so querying rows and columns. So again, let's look at the data. So what kind of a query might I want to do on this data? Like how might I want to select based on rows? What kind of, I've got 207 ministers across different ministries, different ages, right? So what's one kind of a selection I might want to make based, like some subset of rows I might want to choose? Okay, so we can definitely sort, right? So sorting is a different function, and we'll actually look at sort a little bit later. Let's say I'll show you two or three queries right now. The first one is let's look at selecting rows based on a category. Okay, so dat ministry unique. So these are all the different ministries that we have, right? So let's say we only want to choose. Let's say we only want to look at tourism ministers, right? Okay, so in that case, I want to choose rows where the ministry value is equal to tourism. Okay, so the way that you select rows is dat and then the square, your bracket, right? Now inside of this square bracket, you want to put a Boolean expression. A Boolean expression that's going to be true or false. You want this Boolean expression to be true when ministry equals tourism. And you want it to be false when ministry is not equal to tourism. And then that will return all of the tourism rows, right? So you do this by inside of dat, you want a Boolean expression that says, is ministry equal to tourism, yes or no? Okay. So before I actually do the data frame, let's just make this list of Boolean values first. So we can do dat ministry equals tourism. Okay. So this is not a query. This is taking, what's the data type of dat.ministry? So the frame is, dat is a frame, is a data frame, but dat.ministry is one column in that data frame. Do you remember what the data type is of one column? Remember, Pandas has its own special data type for the columns. It's called a series. Yeah. So dat.ministry is a series. If you take a series and you set it equal to equal, like this is the logical equal to some value, okay, and I run that, it's going to give me a Boolean, it's going to give me a column, it's going to give me another series whose values are false or true. Okay. So and in this series, the values are going to be true if ministry was tourism, and it's going to be false if ministry is not equal tourism, right? So you have to understand how to construct these queries, right? Like these series. So you take the series and then you can say equal to tourism. Okay, so now you're going to take that expression. So this is a little bit complicated. You're going to take that expression and you're going to put it inside of here. Okay. So you've got dat with the square bracket, and now you're going to put that expression inside of that square bracket, right? And what that's going to do is it's going to return. So when you write it like this, the data frame knows that you're talking about rows, not columns, right? Because what do columns look like? Columns are a list of strings, right? You're not giving it a list of strings, you're giving it a series with Boolean values. So it knows, okay, this is a query on the rows, right? So if you here, I want the data frame wants all of the rows where ministry equals to tourism. So if I run this, right, and there we go. We got all the tourism ministers, right? What if I want all of the tourism ministers and the justice ministers? Tourism ministers and justice ministers. So think about the logical expression. The logical expression needs to be, right? So the series of Boolean values needs to be true if its ministry is equal to tourism, or, right? Or if ministry equals to justice, right? So the way to do that here is you've got this one expression here, and I'm going to copy and paste it again here, right? And we're going to use the straight line to indicate the or, right? Now I'll run that. Now it's a little bit, it gets a little bit confused when you do it, when you do this, because when you have the equals and then you have the string and this thing, it doesn't know, like, is that a part of the query or not? So here, when you do multiple queries with either and or, you have to put these in parentheses. Right. Okay, so now I have dat ministry equals tourism in parentheses, or, and then the same, and then dat ministry equals justice in parentheses. And now if I run that, right, now I get all the tourism and all the justice ministers, right? Now there's one other way to do this, which is a little bit cleaner. I mean, Pandas has a lot of these kind of functions. You'll find out later. Like, I can't tell you everything, but let's make a list of include ministries equals, I'm just going to make a list. Let's say tourism and justice, and like, let's pick one more. What's another ministry that you want to look at? All right, digital development. So and I call that digital develop, right? So here I'm just gonna create a list: tourism, justice, and digital develop. Okay, now inside of here, instead of doing this equals and a or, right, which is kind of like the basic logical expression, I can use a function on ministry. Okay. So I'm still taking the series dat.ministry, but I'm going to use this function is in, right? So if ministry is in, and then what you put into this is in, the parameter is a list. So you're going to put a list of values, which I've created here, include ministries, right? So I'm just going to put that there. So if ministry is in this list, then it will return true. And if not, it'll return false. Okay? So this is in function is really helpful because it helps you to scale up, right? If you want to do a query on, like, you want to include like things that are in 4 categories, but not in 6 categories, right? And you don't want to do like ministry is like equals equals or equals equals or equals equals or equals equals like, 10 times. So now if you do this, right? So now we've got tourism ministers, we've got the justice minister, and we've got the digital development minister, right? So these are two different ways. You can use a logical expression equals equals with the categorical value, or this is in function to select. You can also select rows, the only kind of logical expression, right? What if we think about right? So term start year, let's say, we have the first presidential administration and then we have the second presidential administration. So like when did Tokayev come into 2019? Yeah, 2019, right? So let's look at all the ministers who were appointed by Tokayev. So how are we gonna, what kind of a query are we gonna construct here to identify start year? So yeah, so term start. So now we're gonna, so we'll take that, and then what do we put in here? Dat dot term start year. We do equals equals, it's only gonna, yeah. So we can do greater than. Or we could, yeah, so we can do greater than 2018, or we can do greater than or equal to 2019, right? And that gives us, these are all the ministers who were appointed after 20, or, in 2019 or afterward, right? 49 ministers, 49 ministers out of the two. Right? I mean, think about how long was Nazarbayev president? He was president for 25 years. 207 ministers minus 49, right, is approximately 160. So Tokayev, Nazarbayev appointed ministers over 25 years. Tokayev has appointed 49 ministers in like 6 years, right? Yeah, so I mean, in my research, this is kind of, these are patterns, right? So that might have been due to 2022, right? There might have been ministers, right? There might, but still, like we could look at a time series to see, like, have those been steady appointments, or was it like all in 2022, right? Or whatever. So okay, but the point is here, like, yeah. So you can use, so for these queries, you can use equals equals. You can use greater than or equal to, less than or equal to. There are other more complicated ones that you can use as well, but these are the basics that I'm going to introduce now. You could also say, like, let's say you want how do we combine these? But I want to know all of the foreign ministers appointed by Tokayev. No. Foreign affairs ministers appointed by Tokayev. Yep. Now again, it was it ministry that I spelled? Yeah. And again, like, it doesn't, if you have multiple expressions, it prefers that you put them in parentheses so you don't confuse the, right? And there I've got, so Tokayev has appointed two foreign affairs ministers, or there have been 2 foreign affairs ministers appointed since 2019, right? So this is how you kind of, now this is all, we're all just selecting on rows. I mean, we're selecting rows based on logical tests of column values, right? You can also select, okay, so the next thing we want to do is select columns. And I showed you this earlier a little bit when we reorganized the columns, but let's just kind of cover it a bit more systematically. So what if for my data, let's say I only really want to look at ministry. I don't really need position. I don't really need name. Let's just say I want ministry and TermStartAge and TermStartYear, right? So, well, first of all, let's just take one at a time. So I can get, again, I'm using the square bracket. Now, if I want ministry, I just put another bracket. Well, first of all, you can put ministry, right? And that'll give you just the ministry series. Now, what's the data type of this? It's a series, right? Now, but if I put in a list, so I'm going to take ministry and let's say term start year. Okay, so I've got the square brackets for the data frame, and inside of that, I'm putting a list with, right? So this is going to return a subset of columns, right? Now it's all selecting any kind of logical criteria on rows. So I get all my rows, but I'm getting just two columns, right? Ministry and term start year. Right? And if I want to add another one here, I can, do birth year, right? Okay, fine. So that's how you can, and if I wanted to save that as a subset, I could do, this is called like table 0, right? It is table 0, and I could export that as an Excel file or whatever I want to do, right? The other thing you can do with this is, and I mentioned this before, you could like put these in any order, right? So they don't have to be in the current order that they're in. So if you do, ministry birth year, oh, I don't want birth year, I want term start age, right? So I get ministry, term start age, term start year, etc. Okay, so that's how I select columns. Okay, Pandas gets so far, so if you want to select rows, you need logical expressions inside of there. If you want to select columns, you need a list with the subset of columns. What if you want to select rows and columns at the same time? So you want to select on a row criteria and you only want certain columns. Okay, you can do the same thing, but you need to add two new things. So if you're doing row and columns, first you need .loc. This is a very strange, I don't know why Pandas can't handle rows and columns at the same time without some weird function. But if you want to do rows, you don't need loc. If you want to do columns, you don't need loc. If you want to do rows and columns together, you need loc. Right? So it's .loc, like location, and then the square brackets. Okay, and now let's do, I'm going to take the same expression. I'm going to put that here. So what rows am I selecting? Foreign Affairs Ministers, 2019. Yeah, selected by, or appointed by TermStartAge. Okay, and now I'm also going to select columns. So I'm going to take this list of columns, and I'm going to, so here's the row selection criteria, comma, put a comma in there, and then the column selection. Okay, and now if you run that, now you get, it's those same two, but I only have the 3 columns, right? So now I've selected rows and columns, a subset of rows and a subset of columns, right? So, and the only difference again is you have to add that .loc and you have to put a comma between the, so on the row side of the comma, it's a logical, it's a Boolean expression, right? A series of Boolean, it's a list of the columns that you want, right? So this is how you do rows and columns together. There's some other functions here besides loc that I'm not going to talk about today, like iloc or xloc. There's some other ones where I think with iloc, you can actually put in numeric indices. So you want like row number 3 through row number 5, and you want column number 2 through column number 4. Yeah, so you could do like say like something like this, right? And it's going to give you whatever rows 3 through 5 and columns 2 to 4. I don't like this. I don't like to hard code indices because later, if you change the order, you like sort or like you add things or take things away, then these indices don't mean they don't mean the same thing anymore. So you can do this. Encourage, right? I always try to code in terms of variables and these kind of logical expressions and lists, not in terms of. It's possible you can do it. Okay, so that's a new covariate, right? So we've been talking about the first president and the second president. Let's create a new covariate indicating whether this minister was appointed by the first president or the second president. Okay, and we're going to just call this term. So how would okay, so first of all, it's going to be that term, right? This is how I create a new column. Right? I'm just going to create this as MP as a null so far. I mean, there are a couple ways to do this, but a null value, right? So I've created a column on the right here with null values. I want to change the values column under certain conditions. Yep. So let's just use the number. Let's just use the number 1 and 2, right? 1 will be the term was under the first president. 2 will be under the second president. Okay. So I choose. So I'm going to use this select the row and column construction to do this. So how am I going to choose which column is it? Yeah, term, right? So I want to select. So I want to select the rows. So how do I identify the terms under the first president? Yeah, what's before 2019? Which variable? Yeah, term start year, right? So I want to find the rows where term start year is less than 2019, right? So the row criteria is going to be that term start year less than 2019, and the column criteria is going to be term, because that's what I want to change, right? So I'm doing dat.loc that term start year less than 2019, right? Criteria I need for the row, comma. Now I'm going to choose. So once I've identified the rows where where term start year is less than 2019, now I need to choose the column term, right? And I just do that like that. Now, if I'm only choosing one column, I don't need a list. I can just put the string. I could also put it in a list and it won't make a difference, right? I could put a list and it could have 1 item or 2 items or 3 items. In this case, anyways, I don't need the list. I can just put the string, right? So those are all now if you just enter that, those are all the term values, right? And you can see the rows 5, 6, 7, 8, 9, like somehow to 1. Selecting all the rows where term start year is less than 2019. In that row, I'm selecting the column term, and I'm now setting those term values in those rows equal to 1. Okay. Okay. So now if you go to dat, right? So some of these 2023, 2022, those are still NAs, right? But the 1994s are one, right? And now again, and now if term start year is greater than or equal to 2019, I'll set it equal to 2. Assumes that I guess float is, you can assume that an integer is a decimal, but you can't assume that a decimal is an integer. So yeah. Okay, so now you can see term 2.0 and 1.0, right? And now I'm just gonna that term equals that term as type int 64. Right, and now they're in 64s. And if I do my dat, that info term is now in 64, right? So now I have a covariate. So this is what I mean by sometimes you're creating a covariate, parsing some information, right? Like you're parsing the year out of a date string or that. Here you're creating a covariate based on a logical value, right? It could be like a year before or after. Sometimes let's say you have a ministry. Let's say you have like a group of ministries that are related to the economy, and then a bunch of ministries that aren't related to the economy, right? And you could create another, which is like, is economic true or false, right? And you could do the same thing. And in that case, you would use the is in function, right? Well, like if the ministry is in this list of ministries which are related to the economy or not, right? And then you could kind of code it that way. So this is just an example of creating a covariate using a row query, actually using a row and a column query, right? Okay, so this is again like one of the most useful things that you can do. You're using the queries in order to create a new covariate. Okay, so now we've only got about 5 minutes left today, but it's fine. Like we can start moving into the group by and aggregation functions. These are a bit faster. I just want to show you count. Okay, so let's look at, of course, tape, and that will tell you how many rows and columns you have. But let's say you want to count the number of ministers in each ministry. Okay, so you would use the group by function. So group by ministry, and then you can just use the count function after that. Right now, okay, a few things I want to say. When you use the group by function, you can put in a list of columns, right? More than one thing. So here I'm grouping by ministry, and then the group by function is always followed by a dot and then some other function, some kind of an aggregation function. So there are two kinds of aggregation functions. One is like a mathematical function like count or mean or standard deviation or maximum or minimum or something else like that. Or there's a function called ag, which allows you to specify like much more complicated requests. So I don't talk about ag today, but I'll just show you count and mean. So, but when you do count, it's going to group by ministry, and then it's going to give you counts of all the other variables. So, but we don't really need this. Let's just say you want to count the number of ministers. right? So actually, these numbers are all pretty much the same. Well, like, why is term start year 17 but position? So the reason is and name don't have any missing values, right? But term start year and birth year and term start age and term do have some missing values. Term has the same number as term start year because if you didn't have term start year, you can't calculate term, right? And term start age also, if you don't have, so, and then, so if you want like the full number of ministers, then you should pick a column that doesn't have any missing values, right? So either position or name. So how do we count the values in name only? Here with group by ministry, after this, you can put a you want, right? So I'm just going to put in name. And now it's performing the function count only on the name variable. Okay. Now, when you're counting, it doesn't matter. But later, when you do the average, it matters because you can't average strings, right? You can only average numeric values, right? So sometimes, if this function requires a numeric value, then you have to select the numeric ones. Otherwise, it's going to throw an error, right? So this is the number of ministers, right? This is the total number of ministers in each ministry. And let's say you want to find out how many ministers in each ministry in the 2 presidential terms, right? So now we're going to group on 2 variables. So in this case, group by, instead of 1 variable, you're going to put a list, ministry and term. Okay. Now we know that term has some missing values, right? So those are not going to be counted. But still, you put this list inside of group by, and now we're grouping on ministry and term. So now we've got two kind of aggregating, or I guess in database key or something like that. And then you're going to count the name. So if we run this, right? So now you can see in agriculture, in the first and second term, you have 14 and 3. Culture, the first and second term, 5 and 1, right? Defense, in the first and second term, 10 and 2, right? What if we want to, okay. So first of all, we'd save this. We'd save this as a, okay. But notice like the column names are kind of weird. Because ministry and term are not being treated as, they're being treated as indices. Okay. So if you want to treat this like a regular data frame, if you want this to be turned into a regular data frame, here inside of the group by function, you add this parameter as index equals false. And I almost always do this because I never need the indices. I just want these to be columns. So if you run it as, now it's just a regular data frame, right? It turns the indices into a regular column, right? And this is more useful for us. So down here, same thing. I'm going to add, inside of the group by, I'm going to add the parameter as index equal. Okay, now it's converted those indices into columns, like regular columns of data, right? And then if I want to, I can, let's say I want to export this. Well, I want to do one more thing. So I'm going to go over a few minutes today, but I really want to get to pivot. So we'll hit the next week. We'll do the aggregation functions on mean. Today we're just doing count, but I really want to hit this pivot. So what if I don't want, what if I want term to be columns, like term 1 and term 2, right? Like I want the count for term 1 and the count for term 2 as columns, right? So right now, this is the form of this data is called long form, right? This is long form because I have the ministry twice, right? And then I have the term 1, term 2. Term is a variable, right? I want to get rid of term as a variable, and I want to pivot. This is called, I want to pivot my table from long to wide on the term variable, right? So I want a column term 1, term 2, right? And by the way, like name shouldn't be name. This should be count, right? Because it's not, these are not names. This is the count on the name variable. So I need to change that anyways. So, okay, so I'm going to pivot here. So first thing I can do with the tab 1 columns, I can change the column names to whatever I want. So I want ministry and what was it, term, and instead of name, I want minister count. Right. So this is one way to rename the columns. So now I've got ministry, term, and minister count. Okay. There's also a rename function if you're just going to rename one at a time, but if you're going to rename like several of them, or if there's this weird, so this, I just prefer to use this kind of columns equals, and then you can, okay. So I want to pivot. So you can go to ChatGPT. I just want you to notice the difference between pivot versus melt in pandas. So pivot, this is actually, I think this is wrong. So pivot is actually long to wide. So if you, so melt converts a wide format data frame into a long one. That's true. So it should say wide to long, right? So these are, ChatGPT is kind of a little bit, maybe I think it has a cold or something. So pivot is actually long to wide. So right now we have the long, right? We have term 1, term 2, and we want it to go wide. So it's term 1 count, term 2 count. So we want to get rid of the term variable, and we want to create new columns. So that's long to wide. So that's pivot. Melt is the opposite. So melt's going to take like term 1, term 2, term 3, and it's going to have a term variable, which is like 1, 2, 3. Okay. So, so here I'm going to pivot. I'm not going to pivot. Now be careful here. I'm not going to pivot dat, right? I'm going to tab, right? And this is the key with the data wrangling, right? Because now like the structure, the shape of my data is different. This table is different than the structure of the original data because I've aggregated, right? So now what I'm wrangling is not the original dat. I'm wrangling tab, okay? So just keep that in mind. So okay, so I've got tab 1 pivot. You have to choose the index, the columns, and the values. So index is the thing that's going to stay the same, right? So in mine, that's the ministry. The ministry is going to stay the same. The columns that I want to pivot are the column or columns that I want to pivot are what? Term. I want to pivot term. That's the one I want to get rid of and turn into columns. And then the values are the numbers that are going to stay in there, right? Which are, in this case, the minister count, right? So here, columns equals term and values equals, now any of these could be, values could all be a list of variables or just a single variable, right? But in this case, it's just a single variable. So the values is going to be minister count. Okay, so if we run that, now you can see I've got ministry. This is term 1 and term 2, where the values are the minister counts. Okay, and now I'm just going to rename this. Columns equals, so I'm going to keep ministry. And then I'm going to, the second column, what should I call the second column? Minister count. So I'll just call it term 1 count and term 2 count. Oops, where's my... okay, but I already changed tab 1 again, so you have to be careful. I have to go back and run my tab 1 all over again because I changed the column names. Okay, so now I've got tab 1, term 1 count, term 2 count, right? So I aggregated, and now I pivoted in order to make, to go from long to wide, right? And I could use the melt function to take this back from wide back to long, right? And then I would, I would take the term 1, term 2 count, and I would make those into, split those into the term and columns value again. Okay, so I've got tab 1. Now, lastly, I'm just going to export this. So this, so file out, so tab 1 out name is, what do I want to call this? Minister counts by term. So I'll just call this minister counts by term .xlsx, right? Everything's good. So I just do tab 1 to XL. Where am I going to save this? What's my path? Yeah. So now I don't want to save. I don't want to be creating new data files, right? I mean, I could, but this is why I have the analysis folder. So any kind of subsets of data, any kind of so I'm going to tab 1 out file or tab 1 out name, whatever. And again, index equals false. So we don't get that index in the beginning, and just run that. Okay. And now if I go to my analysis folder, these are old ones. Okay. All right, and there's my data. No. I forgot to do that. Okay, I got to go back and run it from tab 1. Ministry, what is it? Okay, hold on. Okay, so I've got ministry term minister count. I'm going to pivot ministry term minister count. Okay, right. And then run the columns on that. Why am I getting an error here? Because I'm trying to rename 3 columns, but you see these are in dark black. That means that I forgot to make these right now. Pandas thinks that this is an index and that these two are columns, right? But I need to turn this into a, where did I do that? Oh, again, here. Tab 1 is index false. Okay. Yeah. Okay. When I do pivot, because I call this an index, so yeah, damn, I forgot. Index, it actually creates an index. So how do I make this index not an index and I make it like real data or a column? So sadly, unfortunately, pivot does not have a parameter that allows you to do that. So what you have to do is tab 1 equals tab 1 dot index function. Okay. So reset index function is kind of like this. It's just like with groupby when you have as index equals false, but this is a separate that runs on the data frame. So reset index, and then you can choose to drop or not. Here, I don't want to, if it was a number, I would drop it, but here it's actually the data that I want equals, I don't want to drop it. Drop is false. Okay. Okay, now not an index, it's a series, right? And now I want to rename these. And now I can rename them because I have 3 columns and not 2 columns plus an index, right? So where did I do? Okay, so now I've got 3 columns of data. Okay, now I'll export these. And this should be updated in a second. Okay, so now it's updated. Yeah. Okay, so 23 ministries. Now notice there's some missing values. So some of these ministries may have not been around, right? But so just to recap today, we created some additional covariates. We reordered columns. We exported a data frame as an Excel into Pandas. We covered how to query rows and columns. We created a covariate using a query, and we covered the group on count, and then we pivoted and created another another data table that we exported to Excel. Next week, we'll continue with the group by function. Instead of count, we'll look at, it should also, we'll also look at ag because it's helpful. And then we'll use these subsets, these kind of aggregated subsets to start creating bar graphs or line graphs, right? So this is how we're going to start doing the visualization and also the analysis, like statistical analysis. So you take your raw data, you're going to wrangle it. Usually you're going to aggregate it, add some columns, add some sometimes you add covariates before you aggregate, sometimes you add after you aggregate, depending on what it's a covariate of, right? You construct these new data sets, and then you're going to use those to actually make your visualizations, right? So next week we'll actually start making bar graphs, line graphs, and then in the final week we'll do some statistical tests on those data sets as well. So